So tomorrow's activity is going to be on cell size and transport. Okay. Now, we talked about three methods of cellular transport. We called them the big three. Okay. And the big three were osmosis, diffusion, and active transport. All right. Those were the big three. Now, osmosis moves only what? Water. Okay. And does it move it within the cell or across the membrane? Okay, across the membrane. Okay, what about diffusion? What does it move? Basically anything. Okay. Yeah, particles. Right. Okay. So it can transport anything. Does it transport across the membrane or within the cell? Within the cell. All right. Active transport. Okay. Yeah, smaller materials. Okay, like solutes and things like that. Not everything, because I mean some things would be too big. Okay. And it's also across the membrane, and it uses energy. Okay, so that's how that one works. Now, what we're most concerned about tomorrow is intracellular transport. Okay, that is transport within the cell. Things getting from one place to another within the cell. That is accomplished with diffusion. Now, diffusion's got some real advantages. First off, it's passive, so it's free. Okay? The cell doesn't have to expend any energy to use it. All right? It can transport anything, also an advantage. What's the disadvantage? Okay, can't control where it goes, but it generally goes from high concentration to low concentration, which means generally it gets where it needs to go, provided it doesn't have to go, yeah, well, not just across the membrane, but if somebody over here farts, who's the last to know? Over there, right? In fact, they may never know, right? Because diffusion doesn't work good over long distances. So this is great as long as the cell isn't very big. Okay, now you're probably thinking, Coder, well, all cells are small. Yeah, small, big on a cellular scale. Okay, a very small cell, diffusion works great. Very big cell, it doesn't work very well. Okay, as a cell gets big, diffusion becomes less and less effective, and that's what we're going to be looking at with this activity tomorrow. Okay, so I'll put the words back up tomorrow. You can copy them tomorrow. But okay, in terms of looking at a cell, okay, if we're looking at its surface area and its volume, okay, we want volume to be small and surface area, at least by comparison, to be large. Okay, remember that volume is a three-dimensional thing, and surface area is a two-dimensional thing. All right, so as a cell gets bigger, surface area increases. It obviously has to, but the volume increases faster, exponentially faster, because it's three-dimensional. Okay, if I make something bigger, okay, I only have to multiply essentially two numbers that are bigger. It'll still have the same number of sides. Okay, if I'm making something bigger and I'm looking at its volume, I'm multiplying together three numbers that have gotten bigger. So the volume increases faster than the surface area, and it's the volume through which diffusion has to transport material. So as the volume increases, the effectiveness and speed of diffusion decreases. Okay, so if we're looking at, like, these are two cells. Okay, so the one on the right here is a normal cell, right? The X's and O's and whatever are all just the organelles. If something has to go from this organelle to this organelle, it doesn't have to go very far. So is diffusion going to work? Right? It's just going from high concentration to low concentration. That's not a great distance. It'll probably work just fine. Not all of it's going to get there, but most of it will. Okay. Well, here's that same situation. Now the cell is grown. Okay. It's a lot further. And since it's diffusion, it's a shotgun approach, okay, not much of it is going to get there. Because by the time it gets there, it will spread out. There'll be lots of places in the cell where it's in low concentration, and it'll try to go to all of them. Okay? And so it's not going to transport effectively. across that distance. Okay, it's just like what's going on in Calgary right now. Okay, like if you were in Calgary, let's say 20 years ago, you could drive from one end of Calgary to the other, okay, fairly quickly, like 20 minutes. Can you do that now? No. All right. So what are they building in Calgary to help that situation? Yeah, ring roads, right? So you can just bypass the city. Okay, that's great if you're just trying to get through the city. But if you were, let's say, coming in to Calgary from the south, and you're like driving a semi truck, and you have to get to somewhere in the northwest, okay, and you have to make 3 or 4 stops on the way, is that going to take you a lot longer than it would have 20 years ago? Yeah, because the city has grown, and your ability to transport materials through that space has decreased, because there's more going on. There's just more distance to cover. Okay, diffusion works along the same idea. Okay, so what we're going to look at tomorrow is just mathematically sort of how that works, and then looking at the implications for small versus large cells. All right, so we'll have the Chromebooks tomorrow. You'll have basically the whole period to work on that stuff. Okay, after your quiz on parts of the cell, I'll post that at 3:30 today.